Well, good morning, everyone. I hope you had a good weekend. In our time together today, we will continue in our discussion on internal tables. I put a note here on the whiteboard. Remember that we will not be meeting in person. The dates that are noted here, that's this Wednesday and then next week. I will send you information about videos to watch. Homework 3, which will give you opportunity to begin work with various things related to internal tables. You'll be able to see that after class today, and then after our discussion today, and then the videos that you watch, you should be equipped to be able to do well on that assignment. It will be due not this weekend, but next weekend. So you have a little over almost 2 weeks for your next homework assignment. There are still some people that have not submitted the most recent homework assignments, so I don't want to discuss it in detail, but I do want to open up the floor as we get started here to see if anyone has any questions, either that came up as you were working on the homework or just any other thing that would be useful for us to discuss before we jump into our other material for today. Any questions? Yes, sir.
Getting, like say, writing a line of, or writing something before the parameters, how do you like make them both clear? You
Cannot. Not at this point, based on what we know. Yeah, the standard control flow is for all the parameters to be read in, and then the rest of the control flow commences. And we will see later on there is a way to overcome that, but it requires us to change a number of things about our program that we're not ready to talk about quite yet. So we'll get to that a little bit later.
I thought I was going to do this.
No, we just haven't talked about it yet. Other questions? All right, well, the good news is, at least as far as I'm concerned, once we start getting into internal tables, we will be able to start writing programs that actually do some things with a little bit of meat to them that are more reflective of the kinds of programs that we will write as the semester goes on and as ABAP developers do professionally. We talked last time, or at least we started talking last time, about the concept behind what an internal table is. It is really on a very basic level, it is just a collection of data objects that are all of the same type. It's similar to arrays in other programming languages, but I think it's in fact much easier to use and much more powerful. And although we can use it with any data type, the most common data type for us to use it with is a structure, which gives us the ability to replicate something that within the scope of our program very much looks like a database table, in that it has fields, it has different records in it. And so we use internal tables often parallel to database tables in our programming. And so we were getting ready to get into some of the specifics of this. We talked a little bit about when you're working with an internal table, you can really, the way you access the internal table is very much dependent upon what you do in terms of defining different fields to be key fields. And we'll see that here in just a moment. And so let's get into a little bit more of the logistics and mechanics of internal tables. There are, in fact, 3 different types of internal tables. We have what is called a standard internal table. In a standard internal table, there is no inherent order to the rows. So in that respect, it's very similar to a database table. We could have, for example, a particular database table that we append things onto the end of the database table. We might insert things somewhere in the particular set of records in the database table. But fundamentally, a database table has no inherent order to it. And so that is what we see being replicated here in the idea of a standard table. With a standard standard table, we can access the individual records either by row number, so we can say navigate to the 4th record in a standard table or the 7th row in a standard table, or if we have defined key fields, then we can say find me the record where this particular field value is equal to this. And the system can search on that basis to allow us to access things that are found in a standard table. A sorted table carries with it the concept that the data in the table is sorted by the key fields. And if you will, the way I like to think of this is imagine what we're talking about as an Excel spreadsheet, and we could tell the Excel spreadsheet to sort based on column D, or we could tell it to sort first by column D, then by column A, then by column C. Well, we can do the same thing when we define key fields in a sorted table. We specify the single or multiple fields that we would like the table to be sorted by. The nice thing about this is, as our program progresses and as we modify a sorted table, the system will automatically preserve the defined sort order for us. Now, of course, if we don't care about the sorted order, then asking the system to do that is introducing processing overhead that could be a waste. But if the idea is that the inherent order of these records is important to us, perhaps based on what we're going to do in creating output or some other use of our program, then this is the preferred way of handling it, as opposed to explicitly sorting it ourselves programmatically. We just say that we want this internal table to be sorted, and we let the system take it from there. Like a standard table, a sorted table can be accessed by row number. Give me the 5th record, give me the 12th record, or we can also access it by key values. Show me the records where this particular field equals this particular value. The third type of internal table is not one that we will use very frequently in the context of the kinds of programming we do in this class, but we have a hashed table. If you are familiar with the concept of hashing, then you kind of know how hashed tables work. With a hashed table, the keys have to be unique, and the only way we can access the values in a hash table is by key value access. A hash table has no semantic sense of order. So I cannot step through the table sequentially. I cannot say, show me what is in row 5, but with a hash table I can say, give me the record where the key field matches this particular value. And because you'll note that we have indicated here that the keys have to be unique, I know that specifying a key value pair will only return one record in that situation. This is a much more specialized type of internal table, and because very often in my programs I do want to access things sequentially for a variety of reasons, that is why standard tables and sorted tables are far and away the more common types of tables that are employed. Well, let's actually start looking at some syntax here so that we can be a little bit more precise in our discussion. So how do we create an internal table? Much like creating a structure, we begin with a type definition, and then we'll actually follow that with a data statement that actually creates the internal table. So here's the syntax of internal table creation. We begin with the keyword types, followed by a colon, and then we give our table type a name. Customer table type, airport table type, address table type, whatever have you. We give our table type a name, then we follow that with the keyword type, And then, what kind of table is this? Is it a standard table? Is it a sorted table? Or is it a hash table? And then, what is the table made up of? So, most times, this data type right here is going to be a structured data type. So we might say, for example, types, address table type, type standard table of address records, or whatever it is that we have chosen to call our structured data type. Then we follow that with information about the keys, with, and then either the keyword unique or non-unique key. Even though we might have multiple keys, this word is always singular, and then a list of the key fields, which of course, this is going to be the names of fields that are found in this particular structure type. So let's look at some specific examples. Well, actually, before we do that, let's observe a couple of things here. The data type here could be any data type, but structured type is the most common. So I could have types, integer table, type standard table of I, in which case I'm going to have an array that would hold integers. We don't do that very often, but technically it is possible. Structured is far and away the most common. I do not have to define a key. If I decide that I don't want a key at all, then I just leave off this last portion, the with, unique or non-unique key, and a list of keys. So I can do that depending upon how this table is going to be used in my program. As I noted before, we can have multiple keys, and we're going to see something that ABAP does that's somewhat odd compared to other programming languages. I don't separate these with commas. Remember, commas are how we end statements in chained statements. So we can't use commas here. We just separate the names of fields with spaces. And then lastly, and here's a very important fact that we will undoubtedly reiterate numerous times in our ongoing discussion, a standard table, by definition, can only have non-unique keys. Now you might say, well, I know my data, and with the key that I have selected, the data will be unique in that key field. The key field is Social Security number, and everybody has a unique Social Security number. Well, that's fine, but by definition, if you are creating a standard table, you have to say with non-unique key, and then list the field that you want to be key. A hashed table has to have unique keys. So anytime we say type hashed table of, we have to say with unique key and then designate the key field or fields. A sorted table could be either, depending upon your knowledge of the table in question. You could say unique or non-unique keys, depending upon the data at hand. So let's look at some specific examples of this syntax and talk through it in more detail. This would be, whoops, I guess the order's coming in here oddly, a standard table with no key. So here we see types, standard person table type, type standard table of person struct type. So we'll assume that somewhere in my code prior to this statement, I have defined something called a person struct type. And I have now created a type called standard person table type that I can use later on in a data statement to create an internal table of these person struct types for use in my program. Here would be a standard table with a key field. Types, standard person table type 2, type standard table of person struct type with non-unique key last name. Remember, by definition, as we just observed, we have to have a non-unique key here, and so this would be a very, very common structure. I could say with non-unique key last name space first name. what's the significance of defining a field to be a key field? The standard table. What was that? I can search based on that, okay? So later on we could see that we could write some code that says, give me back the record or records where last name is equal to Smith. But I could not say, give me back the record or records where first name equals Barbara, because first name is not a key field. So when I'm specifying the key field here in a standard table, I have to be mindful of the fact of what fields am I going to want to use perhaps later on in my program to navigate with or to extract data from this internal table. Now remember, as I observed a moment ago, once I have a types statement, that defines the structure, the format, the design of the internal table, but it doesn't actually give me an internal table. To actually get the internal table, I have to use the data statement. So here we see data, my addresses, type, standard person table type. So this would be how we would create a standard table in our program. Now we haven't put anything in it yet. We haven't observed what we can do with it, but we have created the internal table that we can now employ in our program. Any questions about what we are seeing here to this point? Here's another example. These are all going to look very familiar. A sorted table. Types, sorted person table type. Type, sorted table of person struct type with non-unique key last name. So what's going to now happen is as data is loaded into this internal table, the system will preserve the sort order based on last name. However, if we have multiple people with the last name Smith, that's fine. The key is defined to be non-unique, but the Smiths will be in arbitrary order. It's not like Ann Smith will come before Beth Smith. All I know is that the Smiths will appear before the Thompsons, but there's no inherent order beyond last name. If I wanted to sort by last name, then by first name, then by state, perhaps, I could do that by doing last name space, first name space, state. The key there being, of course, that I cannot use a comma, otherwise I break my types statement. Here is a sorted table with unique key, and notice in this instance, I have now added first name to this because I recognize I may have multiple people with the last name Smith. Now, in this instance right here, I cannot have two Beth Smiths in my table, because what I've indicated is that the combination of last name and first name will in fact give me a unique key, and the table will be sorted first by last name and then by first name within that. Questions about this? Yes, sir.
Can you have unique and non-unique keys in like one table?
No. Not at all. Now you could, and I suppose in a very specialized set of circumstances, you could have two tables in your program that are both active at the same time, that have the same data, but are actually one sorted and one standard. I don't know why you do that, but you could do something like that, but it's one or the other. It can't be both at the same time.
So with the unique key, does that mean that only the combination of those fields it can not be unique? So like you said, Beth Smith, as long as there wasn't another Beth Smith, there was a John Smith.
You'd be okay. Absolutely. Yes, sir.
You did say that just because the entry in the database is necessarily unique, it doesn't have to be unique in that statement.
Right. I could have a sorted table that in the fields in the table, I have people's social security number. But in the context of my program, I don't really, I'm not going to use the social security number as a key field. I'm going to use their last name and first name. So even though I know that social security number in the database is a unique key, that does not mean that I have to use it as the key in my program. And so the key here, no pun intended, is to think downstream about how I'm going to be using this data in my program and reflect that in the definition of which fields are key. That's a little bit different, or perhaps quite a bit different, than what we do with database design. Because here, the scope of your focus is just what you're doing in this particular program. Yes, sir?
Which best myth will we capture, the first one or the last one?
Well, if it's a sorted table with unique first name and last name, let's say it starts out empty, and I try and insert a Beth Smith into the table, we're good. When I try and insert a second Beth Smith in the table, I'm going to get an error because I'm undermining the uniqueness.
Oh, error.
Yes. Other questions? And I'm not going to show you a hashed table. We probably will not use a hashed table this semester, but the syntax here would be the same. Type hashed person table, type hashed table of person struct type, and here I would have to do with unique key and specify unique key in order to have a hashed table. When I create an internal table, so if we will, we have the metaphor of something that looks like a database table, something that looks like, if you will, an Excel worksheet, in that I have fields and I have records. This is what I'm getting when I define an internal table. Yes, sir?
And also including filters as well.
Run that by me again?
Filters,
What do you mean?
like when you do an spreadsheet, you always have like data columns and you filter them by ascending or descending order.
Sorting, and yes. So we have that concept here, absolutely. So one of the things that we will typically do in our programs is, this guy is great and this is very, very useful, but we will almost always find it helpful to create a companion to this guy that reflects it being the equivalent of just one line of the table. And as we'll probably discuss later in our time together today, I think the reason or the utility of this would be pretty straightforward. I want to put a new person in this table. So I fill this guy up and then I insert it. Or I want to pull someone out of this table. Well, when I pull it out, I need to put it somewhere, and this is where I'm going to put it. So almost always in our programs, we will create a table, and then we will create this guy right here that matches the structure of the table. And by that I mean, if this is named field 1, field 2, field 3, field 4, this over here matches that exactly, including data types and so on. We give this guy right here a special name, and that's called a work area. And almost always you will see a work area abbreviated SWA. Now we'll talk about this as we go along here. There's lots of different ways to create a work area. But if you think about it, this table is based upon a structured data type. We could use the same structured data type to create this guy over here. The difference is this is just a singular structure, whereas this is a collection. If you think back to the homework program that you turned in over the weekend, where I asked you to create a structure for a book and fill it with data, this is what you did right here. You don't have one of these in the context of the program you wrote at this point, but you did create a singular structure and fill it with data. Well, whenever we create a singular structure to use in conjunction with an internal table, we call this singular structure a work area. And I'll show you some variant syntax that we could use for that. Do be aware of this. In older ABAP programming, and we would have to go back probably 15 years or more before this was common practice, there used to be something called a header line. A header line has a lot in common with the idea of a work area, but it has certain limitations. And header lines were created by changing up the way you declared an internal table to give you a header line for free. But header lines are now considered deprecated. So we don't ever want to use them. For one big reason, when we start doing things with object-oriented ABAP here in a few weeks, they don't work with object-oriented ABAP. If you put a header line in an object-oriented program, it will trigger a syntax error and your program will not pass syntax check. There are other reasons why header lines have been abandoned. So this is another example where I'm pointing this out to you, because maybe if you look online or if you look at older ABAP references, you will see reference to a header line. When you see that, find a different source, because what you are looking at is an older deprecated technique that we do not use in contemporary development. Okay? Well, let's change gears here for just a moment and talk a little bit about database tables, because we want to start writing some programs here that will use internal tables. And you would not like it very much if for your next homework assignment I said, create an internal table capable of holding books and put 50 books in that table. And you had to write the code like you had to write this past weekend or before to fill that table. That would be really, really tedious. So we want to learn how to fill our internal tables with data from database tables. Now, there is an inherent danger in working in a live SAP system and starting to work with database tables. You could mess up a database table that would cause the system to not work correctly. Later on this semester, I will have you write some programs that manipulate data in standard SAP database tables. But as we get started, that's a recipe for danger. So in fact, SAP has created in their standard databases that they deploy a set of tables specifically for use in training purposes. And these are called the airplane or airport flight tables. And they're pre-populated with data, and they're very useful for us to write some practice programs with. So we will use these a lot this semester, with the idea being if you could do stuff with these tables, you could do stuff with other tables too. Now there is a whole collection of these tables, some of which we will use, some of which we will not use. But just to give you information on a few of them, there's a table out there called S Airport, which has information on airports. There's a table out there called SCAR, which has information on airlines. There's a table out there called SP Fly, which contains information on flight schedules. S Book, which contains information on flight bookings, and S Custom, which contains information on flight customers. So we're going to use these a lot in our initial practice. Here's a transaction code to file away in the back of your brain, because you probably will use it a lot this semester. SE16 is a transaction that will let us look at SAP table contents. So let's look at and talk about SE16 here for a moment before we go on to other things. So I'm going to navigate to my SAP GUI. I'm going to open a new GUI window so I can keep my SE80 open. And SE16 And I'm presented with a screen here that just asks me to put in the name of the table I want to look at. So we'll start with one of the training tables I just mentioned, S Airport. Notice we do have a search option here that I could use to search for a table if I knew like it started with something but I didn't know the full name of the table. And then notice here I have 4 buttons in the upper left. I have table contents, I have create entries, which would actually allow me to add a new record to a database table manually by filling in fields on a screen here. User parameters and info, or online manual actually, but I'll just start by typing in the name of my table and hitting enter. And it pulls up an initial screen related to S Airport. Now, as I'll show you in just a moment, some database tables in SAP might have hundreds of thousands or millions of records in it. So one of the things that doesn't happen is when I do this and hit enter, it doesn't go out and give me that entire table and tries to dump it to the screen. It wants to know a little bit more about, okay, what do you want to know about this table? Notice, for example, I have a button here at the top called number of entries. If I click on that, I see that in fact this particular table has 53 rows in it. So this isn't that big a table for me to worry about. Notice other things here. Execute relates to what I see out here on the screen. I can limit the values of what I'm shown here in a moment. And let me illustrate what I'm talking about. If I just at this point hit the check mark, then it is going to actually, if I hit execute rather, it is going to show me the contents of this table. Notice here at the top, and this is something you want to get in the habit of, finding out how many fields there are. And notice this says display fields 4 of 4, and I count 1, 2, 3, 4. The reason why you have to be careful is if a table is really wide, it might be off the right side of the screen, and you can't visually tell that. For example, if there were a 5th field and it was 100 characters wide, I would pick up left and right navigation buttons up here, and I'd have to click the right navigation to scroll the screen. But I might overlook the fact there was even a column over there due to the way it's displayed. But here I see that this particular database table has 4 fields in it. Don't really know the proper pronunciation of this. I'll call it Mont. We will see this a lot in database tables for reasons that will become clear when we start talking about database table design later this semester. What's the significance of this number? Is that something that you recognize?
The system?
Client number. That's our client number. So most database tables will have as one of their key fields a Mont field that is the client. Then we see, if you've traveled much, you recognize this. These are the 3-letter airport codes, the name of the airport, and the time zone that they're in. So this is a fairly simple example of a database table. Now on the last screen, remember I showed you that we could, if we were so inclined, limit what we're shown. For example, I could go back here and instead of looking at the entire table, I could say I just want to see the airports that are in time zone. This guy right here. And it would show me, oh, that's interesting. That did something very, very weird right there. Let me try that again. I think for time zone, UTC -1 was one of the options. I guess not. Well, let's do something that I know we have here. If I did for name, Acapulco, Mexico. it's just going to retrieve the record or records that match what I specify there. So I'm given a variety of ways to navigate, but the big thing that I am interested in is what's finding out what's in the table, which is what this particular transaction allows us to do. Let me just show you one other one here, S-car. If I wanted to look at that, this particular table has 18 records in it. And here's the contents of that. Let's look at a standard SAP table, just for the sake of looking at something different. Mara is a standard SAP table. Number of entries, 52,000. Okay, but notice when I execute here, this is just going to give me the first 500 records in that. And a good thing about Mara is it will let us observe what I was just talking about. You're going to see there are fields off to the right, because in fact Mara has 231 fields in it. Okay, I'm not seeing 231 fields here. And in fact, because of how it was limited back on the last screen, it's only showing me 22 of the fields. But notice I picked up left and right navigation, so I can now scroll to the right and see more of the fields that are there. These are product information. We can see names of bikes and other information about products that our company sells are found in the Mara table. So, that being said, in most of our programs where we are going to be working with database tables, we will use internal tables. And I think we talked about this last time, that we will very often pull data from a database table into an internal table and manipulate it, or otherwise use an internal table in the logical flow of our program. So the very common strategy is fill my internal table with table from a database table. That will, in some instances, involve getting everything in the database table and moving it to an internal table. But more commonly, it will mean getting a subset of all of the fields that reflect what I need to do in my program. And in fact, it may represent meaning, or it may indicate representing, pulling in a subset of all the records. Well, what do I mean by that? I have a database table that contains information on my customers. I track 50 different facts on all my customers. So I have things like their birthday, the number of kids they have, their addresses, how much money they have spent with my company over the years. I track all kinds of information. But in my program, I just want to print out a list of all of my customers with their account number, their first name, and their last name. I do not want to do a select star on the database table and pull in a bunch of information to my internal table that I'm not going to use. If all I need is their first name, last name, and account number, I just want to pull in that information. Additionally, I may want to, in my program, just list my customers that are in Tennessee. So in that case, not only would I be limiting the fields that I'm pulling in, I would be pulling in a subset of all of the records. The key, as we are going to see as we progress this semester, is being very, very wise in what I pull into my program. Because you have to realize, and I've talked with developers that have had an experience like this, they do their development on a development system that has a table in it that maybe has 50,000 records. And their program works just great. And then they deploy it into production, and in production, the table has 5 million records in it. And all of a sudden, the performance of their program plummets because they did not write their program very wisely, And in their program, they did the equivalent of a select star, which wasn't a big deal when you had 50,000 records, but when you have 5 million records now, that's a much more intensive operation to put onto the computer. So we have to be really, really careful about this table filling operation. So we fill the internal table with desired data. We use the internal table as we desire. We dump something to the screen. We paint a table on the screen. Maybe we do some manipulation to the internal table. Maybe, for example, in Johnson City, Tennessee, the postmaster decided to change the zip code from 37615 to 37684. And so we have to go in and change the zip code of all of the customers that live in that locale. Well, it's dangerous to do it directly on the database table. So we might pull those customer records into an internal table, make the modification to our internal table, check it, and then once we're happy with it, use that then to update the database table. And so that's a very, very common control flow that we will use extensively in our programs that we write this semester. I will tell you that there is a lot in common between the syntax for working with an internal table and the syntax for working with a database table, but they're not identical. So keeping these straight can be particularly challenging as you start writing your first programs. You will likely have to refer back to your notes and other references, and certainly do that. The hope being that after you do this for a while, it will become more easy for you to do this without needing those references. So, very common scenario. I want to create an internal table that matches the structure of a database table. As I just observed, a lot of times we will pull data from a database table into an internal table. So I want the structure of my internal table to mirror the structure of my database table. If my internal table will encompass all of the fields of the database table, I pick up a shortcut. And I can use the name of the database table in my table creation syntax. So ignore the rest of the text and let's just focus on the gray box here. I can do data iTable, type, standard, sorted, or perhaps hashed, table of, and then list the database table name instead of the name of the structure. Now, I didn't show it here, but I could continue on with key fields, blah, 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 blah. But the idea here is, this is now going to give me an internal table where the fields in that internal table match the name and data type of a database table exactly. This is a great technique if, for example, I'm using the S airport table we just looked at that only has 4 fields in it. And I need all 4 of those fields in my program. So that's not a bad deal. But if the database table has 85 fields in it, and in my program I only need 3 of those fields, this is bad news. I would not want to do this. So if the internal table will encompass only some of the database table fields, we define our own structure and base your internal table on that structure. Okay? So I have 2 choices. Am I using all of the fields in the database table? And when I say this, it's understood that Mont is such a small field that I don't worry about it. So if the table has 7 fields, one of which is Mont, and I'm going to use the 6 fields in my program, then I use the technique that's shown here in the box. But if the table has 50 fields in it and I only need 4 of them, then what I'm going to have to do is go back and define my own structure. Okay? how do I, so let's talk about the top part here. Any questions about this? All right, we'll write some programs that show this in a moment, but this is pretty straightforward. Data I table, type standard table of S airport with with non-unique key field, or with non-unique key name, would be the way that would look. Any questions about that? Okay, so let's talk about this second scenario then. If my internal table will encompass only some of the database table fields. What I'm about to tell you is critically important, not only for the sake of getting really good scores on your homework in the future, but in ongoing ABAP database design. When you create a database, every one of these fields not only has a name, it has a data type associated with it. We will see later on in the semester the way you define data types when you create a database table is much more precise than what we have been doing to this point. But the key is I want the data type in my program to mirror the data type of every field precisely. What I would not want is the equivalent of this field being able to be 40 characters long, and for some reason in my program, I'm using a data type that can only store 36 characters. So what I do always is I work very hard to make the data types in my program exactly the same as the data types of these fields. So how do I figure out the data types of these fields? Let me show you a precise answer, and then let me show you a shortcut. SE11 is an interface to the ABAP dictionary. So let me go to SE11 and choose. It's actually chosen by default here, the radio button next to database table. And I'm going to go back to our friend, the S airport table. And I'm going to click display. Now, I could look at the contents of this table if I wanted to. That's what this button right here does, contents. And this is going to show me something that looks very similar to what we looked at just a moment ago. But when I go into this from the ABAP dictionary, the initial screen is not the contents of the table. The initial screen is the metadata for the database table. And this gives me the name of the field, what happens to be a key field in the database table, whether the field is required to be populated by data or not, and this right here, it's called the data element. This is the data type. And what's unfortunate here is, it's hard to see on the screen, but this is actually S_Mont, S_Airport, S_Airname, and S_Tzone. So let's imagine, for the sake of argument, that I was going to write a program, and all I wanted out of this was to pull in the ID and the name. So I don't care about the time zone, and I don't really care about Mont. And let's just assume, for the sake of argument, there are a lot of other fields here too. But all I care about is those two. So what I'm going to have to do is I'm going to have to use a type statement to create a structure. And that structure would need to have the fields in it, ID and name. And the type of these would have to match the type of these fields. So that means I could do ID, and I'm using kind of some pseudocode here, ID type _S airport, name type S_air name. And that's how I could create a structure that then I could create an internal table based on, that then I could fill with information. This is technique number one. Any questions about this? Yes,
So
sir.
the scope of the database right there, it allows you to pull, I mean, those seem like user-defined types instead of like universal.
These are universal types.
They are.
We'll see that later on, but when I define a data type in my database, I have to have the typing be based on other elements that are in the data dictionary as well. So, yeah, we haven't talked about it, but yeah, those are in fact global data types.
Okay.
So when I told you guys that we had, however many data types, I and D and whatever, in reality, in most active ABAP systems, SAP ERP systems, you're going to have hundreds, if not thousands, of data types. Where, in addition to those universal ones, you're going to see data types like this. And notice, you see a little bit of the semantic meaning of this. An ID is, in fact, character data type 3 letters long. An airport name is character data type of 25. There's a lot more information beyond what we're looking at now that we'll get into later in the semester, but that at least gives you a semantic sense of it. Questions about this?
So the data types in your structure must match the data types in the table.
Yes. Now let's talk about why. This is getting downstream a little bit. But if I decide, the FAA decides that airport codes can no longer be just 3 letters long because that doesn't give us enough letters, so they move to a 6-letter code. If I come back in and modify the definition of the S_airport data type to be 6 characters long, as soon as I change the definition of that data type in the data dictionary, that has updated my program as well. Because I'm using the same data type anytime I reference that information. The downside would be if I wrote in my program that ID was type C length 3. I've now diverged from that. And if at some point this data type gets changed, it may break my program. But as long as I'm unified in my use of data types here, I have future perfection or future protection when maintenance might be done. Now, I put a 1 next to that because there's another way we could do this. Remember way back when we were talking about the data statement and typing, and I told you that there was the keyword right? I could do something like this. Structure ID like S airport, name of my table, airport, dash, name of my field. That saves me from having to go and look it up and has my program go and look it up. I'm getting to the same destination. Ultimately, though, one is a little bit more straightforward than the other. Okay? So we'll practice with these a lot. You'll get an opportunity to do that in your programs. But the idea is option, I guess, 0, if we stick with my numbering scheme here. Option 0 is if I want the whole table, then I just incorporate that into my definition of the standard table or sorted table or whatever. If I want a subset of the fields, I have to create a structure definition, and in that structure definition, I pick out the fields. I always make sure the field names match, and I either explicitly list the types, or I use the like statement to list the name of the table dash the name of the field. Questions about any of that? All right. Remember I told you a second ago about the work area? Here's I don't know why my slides are coming in bad order. I'll have to fix that. Here's the way I can create a work area very, very simply. If I create my internal table first, I can put in the line of code data WA like line of iTable, and that will give me a single structure that matches the fields and types, etc., of what I find in my internal table. So that line of code right there shows up in most of the programs we write with internal tables, where literally the only thing we change is this right here. Data WA like line of blah is pretty common to see in ABAP programs, and you know that WA is your work area that matches the structure of your internal table. If you had multiple internal tables, you might need a better name than WA. You might have to define which WA goes with which table, but if you only have one internal table, data WA like line of the name of the internal table, and keep in mind this is not the internal table type, this is the internal table data object. So like line of my customers, like line of my airports. The contents of an internal table can be filled from a database table in one operation known as an array fetch. I put a select star there just because it's really simple syntax, but later on in the semester, of course, we're going to have to refine our select statements. But select star from database table into table iTable will go out and grab everything in the database table and stuff it into my internal table named iTable. It is a very good idea to get in the habit of using some additional keywords in your select statement. Let's say, for example, I have a database table that the fields, I have a field called ID, I have a field called name, and of course the fields generally have an inherent order to them. With a select star, it's going to basically take the first field and put it in the first column, take the second field and put it in the second column, so on and so forth. There's a danger here if I have made a mistake in my program and gotten some things out of order, that I could wind up with the wrong data in the wrong fields, which is bad news all the way around. So one way to protect myself from that is to add to this statement here the into corresponding fields of. So the syntax here, I think, looks pretty straightforward. Select field 1, field 2 from database table into corresponding fields of table and then my internal table. And that will give me name matching. So let's play around a little bit with this. For your homework, I have you manipulate the airport table. So we're not going to manipulate the, or do I have you manipulate the carrier table? Let me look real quick at your homework because I don't want to do in class right now what I asked you to do for homework, but I do want to do something similar to it. So let me real quick check and see what I asked you to do for your homework. Which, by the way, your homework will be available to you. I think it opens up at 10 o'clock today. Yeah, I have you use S Airport. So we will not use S Airport. We're going to use the, and I'll just put a note here at the top, we're going to use the S car table for this particular example. Okay, so I need an internal table. I am going to use every field in S car. So if I go over here to my ABAP dictionary, if I want to look at S car, has the fields carrier ID, carrier name, currency code, and URL. Or I could look at this, and here's the fields we have. So like AA is American Airlines, and they use US dollars. And notice I can't tell, but if I scroll to the right, well, that's interesting. It doesn't want to show me the fifth field out there. It's displaying fields. It only showed me 4 of them. There's actually a URL out there that for some reason it's, oh, I think it's because the width of the output list. Let's make this 500. That's kind of a, I don't have to do that. There we go. So now we picked up the URL there. So that's what's in that database table. And for my example right now, let's assume we're going to use all of those fields in our programs. So I don't have to create my own structured type. That's one reason why we're starting with this. And so I'll do this. Data, iTable, type, sorted, table of, scar, with, and I know the keys are unique, with unique key, and here I do have to know a little bit about my table, so I'll very commonly have 2 windows up where I bounce back and forth, and I'm going to use carried as the key. That's the 2-letter abbreviation with unique key, carried. So I don't have a type statement here. I jumped right to creating my internal table. And as I observed a moment ago, almost always the next line is going to be data WA like line of iTable. If you just have one internal table in your program, and it's obvious from the overall logic of your program how you're using it, I don't mind iTable as the name of the internal table. It's pretty common. If you have multiple internal tables, then you're going to need some way to disambiguate them. At this point, of course, I've created an internal table, I've created a work area. I haven't populated it yet, though. So, select star from scar into, and I'm going to do exactly what I suggested a moment ago, corresponding fields of iTable. So this is an array fetch operation. I have just fetched everything from that database table and put it into my internal table. Now, I'm going to do this for a reason that'll become obvious here in a moment. Right, hi. Okay? So let's use something we talked about previously to prove what I just said to be true. I'm going to save and activate my program. Interesting, activate despite errors or problems detected. Well, let's find out what's up with that. Check. Syntax error. Incorrect, the control structure select by, oh. I'm so glad I did not make this mistake on purpose, but I did make a mistake. And it's triggered that error message. There's a problem on line 13 in my program. Anybody pick up on what it is? Subtle. The syntax, and if you check your PowerPoint slide, you will see this to be true. The syntax of this, what's that?
And select.
No, I could fix it. That wouldn't be a good way to fix it. Select whatever from whatever into corresponding fields of, I'm missing a keyword right here. Let's make sure my PowerPoint slide is right. Into table, and then the name of the table. When I don't put that there, it doesn't think that iTable's an internal table, which is what's triggered the rest of the issues here. So I'll put that in. and then a syntax check, and we're good to go. Easy, easy mistake to make, as evidenced by the fact that I just made it. Okay, so what I was about to do is I'm going to activate this, and I'm going to do what we talked about previously, which is let's use the debugger on this. So I just put in a breakpoint there next to line 15, and I'm going to run my program now, and it will of course show me out to the debugger when it hits line 15, which is why I had to put the right there, even though it doesn't do anything. And remember before, we could look at the contents of something by just double clicking into it? Well, I want to see what's in my internal table. So I double click on the name of it, which is iTable. And I'm looking for it here. Part of the problem with my resolution is we lose some stuff. So let's go back and try and make this easier. So iTable is the name of my table. And there we go. Finally it showed up. So it tells me that iTable down here at the bottom is a sorted table. And in fact, if I double click on this, it shows me what's been loaded up in my internal table. So I can in fact see that my internal table did get loaded up correctly, and I specified that the key field in my sorted table was carrier ID, and so you see it did sort by that particular field name automatically for me. Well, I'm going to jump ahead just a little bit in my program here just to show you this, although I'm not ready to talk about it in detail, but let me just finish this up. I want to write this to output. You will get to watch a video that talks about the loop at control structure, and I'm going to loop at my iTable, which will step through that table into WA. So I have now created a line of code that's going to loop through my internal table, pulling off a record at a time and stuffing it into WA. And then I'm going to do this. I'm going to write to output a new line followed by WA dash, and what were the name of my fields again? Carid car name. WA carid, WA dash, is it 2 R's? Car name? Cur code URL. And then I'm going to end loop. Now, I would want to think about column placement here. I didn't put a header at the top of this. Those are things that you got to practice for your last homework. We won't talk about it here, but let's just assume that column 6 will work there, and column 40 will work here, and column 50 will work here. So now I'm going to save this. I'm going to activate this, and I'm going to run this. Oh, interesting. Normally, when you activate, you lose the debugger, but you don't anymore in the new version. So here's what my program just did. I loaded up an internal table, didn't do any modifications or anything, and then looped through the internal table and just dumped the results to the screen. Questions about any of that? So a pretty common thing for me to do in my program, with the exception that a lot of times I'll do some modifications, but a lot of what ABAP developers do is write programs that do reporting. And so my select might be a little bit more sophisticated in a real-world application. My output might be a little bit more sophisticated looking, but the kind of program that we just wrote is the sort of program that gets written a lot in ABAP with just a little bit more sophistication added in the back-end processing. So I haven't really shown you in this program how we would define a custom structure. We put that on the whiteboard and talked about the syntax of it by way of PowerPoint slides, but we haven't written a full program that shows that. But you will get to see that in the videos that you're going to get a chance to watch. Questions about any of this? Yes, sir.
So the initial line, or the first row of the WA is for labels, correct?
WA is a just like a structure like you created for your last homework program. So the fields have names, but they're not a part of the data structure itself. They're a way of putting things in the right places.
So before you do the loop, you could append the first row with...
Yeah, I could modify what's in the internal table. I could American Airlines went out of business, I could delete American Airlines. I could add a new airline, and in fact, you're going to do exactly that for your next homework assignment. But you're going to have to watch a couple more videos to learn how to do that. So let me talk about this. What I'm actually going to put up in D2L for you is, and I'm going to be away on business, so that's why we're going to have to miss some classes here. But the videos that you'll get to watch are from last year's class. So you should find it to be parallel to what we're doing this semester with a little bit more code and stuff mixed in. So what I'm going to do is I'm going to tell you what videos to watch, and once you watch even a portion of those, you should know enough to do your next homework assignment. So homework 3, like I mentioned, is not due this next weekend, but the weekend after that. But I would encourage you to watch the videos soon and to take time on your homework. I will be available via email, but during the day I'll be in conference sessions, so there might be a longer delay in my getting back to you than I usually try and achieve when I'm here in the office. But basically what you're going to do is watch some videos on internal tables and then do a homework program related to that. And then when I get back, the next class session after the 21st, we'll kind of do a review of internal tables, make sure we're all on the same page, answer any questions you might have. And then sometime pretty soon after that, it'll be time for spring break. And then I think your midterm exam shows up right after spring break this semester. Any questions before we call our time together to a close this morning? All right, if you did not sign in, please make sure you do that. But I'll look forward to seeing you guys in a couple weeks when I get back to town.